Did you know the sun isn't just going to burn out like an old candle, but it's actually going to eat the Earth first? We take its warmth for granted, but deep inside the sun, a violent fuel crisis is building up that will eventually destroy us all. Ignoring this reality means missing out on understanding the wildest transformation in our solar system's entire history. You need to watch until the end to discover the one surprising thing that will actually survive the sun's explosive death. It feels permanent, doesn't it? The sun rises, it sets, and it provides the energy for almost every living thing on Earth. It has been doing this for roughly 4.6 billion years. It is the steadfast heart of our solar system, its gravity holding everything from tiny asteroids to giant Jupiter in place. Because it's always been there, we naturally assume it always will be. But the universe doesn't work like that. Nothing lasts forever, not even stars. Especially not stars. The sun is not a magical ball of infinite light. It is a physical object, a massive engine operating under the strict laws of physics. And like any engine, eventually it's going to run out of gas. To understand how it dies, we first need to understand how it lives. Right now, our sun is in the prime of its life. Astronomers call this phase the main sequence. It's essentially a gigantic ball of superheated hydrogen gas. In the very center of the sun, the core, the pressure is so intense and the temperatures are so high, millions of degrees, that hydrogen atoms are literally smashed together to create helium atoms. This process is called nuclear fusion. Every single second, the sun converts 600 million tons of hydrogen into helium. This fusion process releases an unbelievable amount of energy. That energy pushes outwards, trying to blow the sun apart, but at the same time, the sun's massive gravity is pulling everything inwards, trying to crush it. Right now, those two forces are perfectly balanced. The outward push of energy equals the inward pull of gravity. This balance is what keeps the sun stable, round, and shining consistently. It's a delicate dance that has continued for billions of years. But the music can't last forever because the hydrogen fuel is finite. So, when does the party end? Scientists estimate our sun has about another 5 billion years left in its current stable state. That sounds like a long time, and it is. You don't need to panic today, but the changes will start happening slowly long before the final end. As the sun burns through its hydrogen core, things get complicated. The core, now mostly heavy helium, will start to shrink under gravity. This shrinking makes the core get even hotter. Paradoxically, as the center gets hotter and smaller, the outer layers of the sun will get pushed further away. This is the beginning of the end. The sun will start to swell up. Over hundreds of millions of years, it will grow to incredible sizes, becoming what astronomers call a red giant. This isn't just a small change. The sun will become so enormous that it will swallow up the inner planets. Mercury is the first to go, vaporized inside the expanding star. Then Venus will be consumed. This brings us to the ultimate question: what about Earth? This is the part that keeps astronomers up at night. As the sun expands into a red giant, its surface will get dangerously close to our planet. The heat will become unimaginable. The oceans on Earth will boil away completely. The atmosphere will be blown off into space. The ground itself will likely melt into a sea of lava. There is a debate among scientists about whether the expanding sun will actually swallow the Earth entirely like it did Venus, or if the sun will lose enough mass during its expansion that its gravity weakens, allowing Earth to drift just far enough away to avoid being eaten. But either way, the outcome for life is the same. Earth will be a burnt cinder, completely sterilized. Nothing we recognize today could possibly survive that phase. But the drama isn't over yet. The red giant phase is unstable. The sun will eventually become frantic, pulsing violently. Finally, in a spectacular series of events, it will blow its entire outer atmosphere off into space. These ejected layers of glowing gas will travel outwards, creating a beautiful, colorful bubble around the dead star. We call this a planetary nebula. If you've ever seen pictures from the Hubble or James Webb telescopes of colorful ring-like clouds in deep space, you are looking at the ghosts of dead stars similar to our sun. It will be a stunning cosmic tombstone. Once those outer layers are blown away, what is left? Right in the center, where the mighty furnace once burned, there will be a tiny, incredibly dense core of carbon and oxygen. It will be about the size of Earth, but it will contain about half the mass of the original sun. This leftover core is called a white dwarf.
This white dwarf is the final fate of our sun. No more fusion, no more fire. It is just a slowly cooling ember in the vast coldness of space. It will still shine with stored heat for billions of years, but it will emit a feeble white light, offering no warmth to the charred remains of the solar system. Eventually, over trillions of years, even that heat will fade away. The white dwarf will cool down completely and become a black dwarf, a cold, dark lump of matter floating through the galaxy, invisible and forgotten. It's a somber ending to the magnificent story of our star. But remember, this is the natural life cycle of the universe. We're here today, able to learn about this incredible future because we exist in that perfect golden window of time when the sun is stable, warm, and generous. So the next time you feel the sunshine on your face, take a moment to appreciate the mighty engine that makes it possible and the incredibly long, dramatic future that awaits it.